Hello, I'm Nandini Potter. I'm doing my master's in electrical and computer engineering in University of Florida. I will be presenting a project on performance evaluation of orthogonal space-time block code concatenated with Trellis-Coded Modulation over a MIMO Fading Channel for my wireless communication class EEL6509. What's an orthogonal space-time block code? An orthogonal space-time block code is a block code that has a high diversity factor but a very low coding gain, while a trellis-coded modulation is one which works only in a SISO channel but has a very high coding gain. An orthogonal space-time block code is very effective in an MIMO fading channel. You may ask, why is a multiple input multiple output channel much better than a serial input serial output channel? A multiple and multiple output channel has more number of antennas in the receiver and the transmitter side, thus decreasing the error rate and increasing the accuracy of the signal and the speed of accuracy, etc. Therefore, but we still need to have proper block codes for such a system. The trellis code modulation would act as an outer code, while the orthogonal spacetime block code would act like the inner code. This together would give a much better block code, which would cause having a less frame error rate for this system. This is the basic block diagram behind what I'm trying to say, and my contribution to this is by changing the number of antennas in the receiver and the transmitter side and trying to find the performance and how it changes in the receiver and transmitter side. If you see that PSK TCM encoder, I would like to show the PSK TCM encoder in my MATLAB code while I explain. This is my OSTBC TCM code, but I like to show my PSK TCM code and try to explain what a TCM encoder basically does. A TCM encoder, the one that have been implemented in this project, is a PSK TCM demodulator and a PSK TCM modulator. The PSK TCM modulator acts on is basically where it takes the trellis input into the system. It tries to send it into, and the output will be sent into the OSTBC encoder. Here the PSK TCM modulator would be sending the output as in the form of a vector signal. Here it's truncated. Truncated means that at every frame, all the values of the encoder would be reset at every point. The demodulator will be basically converting the input signal, keeping the trellis as a base, into the output signal. Therefore, trying to make sure that zero error is being made, or trying to reduce the frame error rate at least. But the problem with such a system is that it can only work in a SISO module system. That means it can only work into one system, that's a TCM. While that of an OSTBC would be having it will be running only with an OSTBC encoder and a combiner. The OSTBC encoder basically takes this input signal in the form of a vector and will be sending it in terms of packages over the channel signal. This is basically using the allo-mount encoder, and allo-mount code is basically used for this type of signal. But this is from multiple outputs. So have you seen, I would have given initialized the number of antennas in the transmitter side as a variable A and T. This variable A and T basically would prove that this basic variable A and T would basically prove that I can keep changing the antenna rates, and I've got the different values and I plotted it. While that in the OSTBC TCM, it would be both using a PSK TCK modulator and an allo-mount encoder, and the same demodulators for both. Here they'll be using an AWGN channel as being used. As I would like to go back and talk about the channels before I explain the working of my MATLAB code of an OSTBC plus TCM encoder. There are two types of noises that will be included. One is the AWGN channel noise and the other is the Rayleigh fading channel noise. The AWGN channel noise basically gives a white Gaussian noise as a receiver noise into the into your channel. This had simulated through this through the code which I've got through the MATLAB communication toolbox. This is the com.awg.channel. Here we can check for the different sound noise ratios. We can plot the graph because you need to know which is the best sound noise, at what sound noise ratio the frame error is the least, because that would prove in creating a better system. So so you can keep changing the noise ratio in your channel by changing the SNR value here. Another form of noise would be the flat rayleigh noise, which would be caused is a flat rayleigh noise, which is type of constant throughout the channel, and that is being implemented through the MIMO channel noise. Here you can see that the MIMO channel would have like a different variables. That's the maximum Doppler effect, number of transmitters, number of receivers, number of correlation matrix, the random stream, the path gain output port. All these need to be initialized for a MIMO channel. The basic thing that I would be changing for the MIMO channel is the number of transmitting and receiving antennas on both the sides. If you see the output for this, we would have seen that is the frame error rate to this. So here we need to keep changing the antennas, plot a lot of values, and check the graph and compare the graphs to see which one has a better coding gain, which one has a better diversity factor, and which one should be used, or which one is more effective in usage. I plotted all the values before, and I've derived all the values of SNR versus FER is shown in this Excel sheet, and I've even plotted using MATLAB. I'm going to be presenting it in a PowerPoint presentation form. This is the results. The Trellis-Coded Modulation is in a SISO system, that's a 1:1 system. Here it will be basically it's a 1:1 system, therefore there's only one antenna in the receiver signal and there's one antenna in the transmitter signal. This is basically used as a reference because the Trellis code does have a good coding gain, but basically we need to be able to compare to know which one has a better coding gain and which one does that. And this is an uncoded system, so this is we keeping it as a base. This is the basic comparison between OSTBC plus TCM. If you see here, the TCM is a reference, while that of the OSTBC has a coding, does have a little improvement in the coding gain, but not the needed or the better requirement. But if you see the concatenated of OSTBC plus TCM has a much higher coding gain than that of OSTBC. The OSTBC plus TCM does have the same diversity factor. This has a better coding gain. Now I would like to show my contribution for this project, that is how I have changed the number of antennas in the transmitter and receiver side for both the schemes, and what the difference is and what I imply from the differences. If you see here, this is basically an OSTBC scheme. Here, on changing the number of antennas in the transmitter side seems to have proven to have a small difference, but changing it in the receiver side seems to have had no difference. Like it's almost the same and it seems to be varying. So therefore, this is because OSTBC does not have any inbuilt code gaining scheme, while that of TCM has a better one. If you see the new concatenated scheme of OSTBC plus TCM, you'll be seeing that the that in this MIMO system of the concatenated scheme, the 2:1 system is used as a reference, while that in the 2:2 system has a much better coding gain, and the 3:2 system has a much better coding gain too. That means it does not just depend on the number of antennas in the receivers or the transmitter side, but it depends on the type of the scheme that we use. So therefore, it has been proved that using this concatenated scheme is the best scheme, and by increasing the number of antennas not only in the receiver side but also in the transmitter side has proven to be effective to be giving a low frame error rate. Here all the simulations here have been done through MATLAB script files, and I've taken the help of the MATLAB communication toolbox, and I've taken the help of using the MATLAB communication toolboxes, which has proven to be effective. I've learned a lot about the different toolboxes and the communication toolboxes. My new input was into learning more about the new aspects of TCM modulation, and I've also come across many new techniques of how the different MIMO systems work, and how there are different block codes that have been used to make the modulation effective in all these MIMO systems. Hope my presentation has been informative and you could get through all my points. Thank you.